Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I'll introduce Microsoft Azure Storage Services. And then in upcoming modules, we're going to flesh out the concepts we discuss here in great detail. We'll spend 10 or 12 modules total talking about the various facets of Microsoft Azure Storage Services, how they can be used, the different features of each of the services, and so on. So Microsoft Azure Storage Services is the original Microsoft cloud-based durable data storage option. It's both highly scalable to support many queries at the same time and to store massive quantities of data, and it's also highly available with redundancy baked into the service. So Azure Storage Services really consists of three types of data storage. The first is tables, so Azure Storage Tables, blobs, or rather Azure Storage Blobs, and then queues, Azure Storage Queues. There's also a fourth service or type of data that kind of falls into the same category, the Azure File Storage. File storage is technically also part of the Azure Storage family. However, it's more like a traditional file server. I kind of think of it as like a network share in the cloud, and it's not really the kind of application-based durable data storage that I'm talking about in this course. Maybe we'll look at it briefly in the next course. But in a nutshell, let's take a look at the major features or the major use cases for each of these three services: tables, blobs, and queues. We'll start with tables, my favorite of the three. An Azure Storage table stores data as entities, and each entity can store up to 255 properties, and a property is a name value pair. All right, so let me give you an example. We may have a table called customers. Customers may have one property for one entity called customer name, and it's set equal to Bob Tabor. Now, another customer in that same table does not have to have the name equal property. That's one of the gotchas with regards to Azure Storage Tables. It makes storage very flexible because each entity can have only those properties that are really descriptive of that particular entity, but it also makes it a little bit difficult to work with programmatically. We're not used to working with dynamic objects as C# developers, not as much as in other programming languages. But we're going to address that in an upcoming module. And as you think of tables, your brain may want to draw parallels between Azure Storage Tables and tables that you find in like relational database management systems, SQL Server, obviously. After all, when you see data represented, even in Visual Studio, you'll see data from an Azure Storage Table represented in a tabular format, just like you would see data from SQL Server in a tabular format, represented on a web page or in some tool. However, Azure Table Storage has no notion of relationships or constraints. It doesn't have the notion of columns or data types or anything of the sort. And so, as I said earlier, two different entities could have two different sets of properties describing those entities. So while there are definitely some parallels, I mean, you can store data in both tables from SQL Server and tables from Azure Storage Tables, it's an entirely different beast altogether. So you might wonder to yourself, well, where does that make sense? Why would you ever use this then? The biggest advantage to Azure Storage Tables is the massive amount of data that can be stored in a single table, and yet you're not wasting space with columns that are not filled with data. So if you can flatten out your data and not have so many relations between the data, then Azure Storage Tables might be a really good option for you. I think, as I said earlier, the maximum size of a SQL Server database is 150 gigabytes, whereas the maximum size of an Azure Storage Table is 200 terabytes. So you can store a lot of data, and we'll talk about how that's possible when we get into more depth and how tables are partitioned to allow for that massive horizontal expandability. The next type of storage service is blobs, and blob stands for binary large object. So think of any binary based data document. That could be an image Or like I suggested in the previous, I think two modules back, a large serialized graph of objects could also be stored into a blob. So blobs are used to store everything from virtual machine disks to log files to origin folders for Azure's content delivery network. And you can use Azure Storage blobs in your application to store really big things. So pictures or videos or documents that have been uploaded by users. And then you can also, as we saw with web jobs, you can trigger a web job to run whenever the data inside of a container changes. And there are some examples out there where somebody uploads a photo to a blob, and then a web job picks it up immediately and then does some image processing on that user uploaded image file. So blobs are just binary large objects, and they're stored inside of a blob container or just a container. And like Azure Storage tables, Azure Storage blob containers can hold a massive amount of data. And so I like to think of blob containers like a big shipping container that you see on the back of a semi, or that you'll see, on a big shipping vessel across the ocean. And inside of every one of those shipping containers, I can put a lot of boxes of various sizes that I want to send somewhere, or that I want to just kind of keep together inside of that container. Now, inside of each of those little boxes, it could contain a picture or a document or a virtual machine hard disk or a serialized object graph or whatever you can translate into bits and then store in one of these boxes. And let's take a look at one of the, at a storage account that I've already set up. Take a look at this one, Hero versus Robot, and I think I have some containers in here. Yeah. So you'll notice that there's a URL for each container and each blob inside of a container. So I'm looking at an account called Hero versus Robot, and then I'm going to look at a container called Blob Lease or Blob SAS or Blob Secure or Blob Example. And inside of each of those, there might be individual blobs that are stored there. All right, and we'll come back to this idea and see how to store things, how to read things out of it, how to lock a blob so that you have exclusive write access to that file, and so on in upcoming lessons. And then the third of the Azure Storage services is Azure Storage Queues. And a queue is just like a waiting line, like a queue that you would stand in line for a bank and wait your turn until the next teller opens up to address your particular issue. So it's a waiting line for individual messages, and this opens up lots of interesting architectural possibilities and makes our applications much more flexible and scalable. So one application could put a message on a queue, and then the message waits in line and waits its turn, and then another application reads the message off the queue and processes it, and if it processes it within a certain amount of time, then that message will be removed from the queue. If it fails to process that message within a certain amount of time, then the message will be re-added to the back of the queue, and it'll be attempted to be read by some other process in the future. And so what can you store inside of these queue messages? You can create some sort of file format yourself. A popular option for software developers is to serialize an object or a graph of objects and pass them from one application to another application. You can also use comma delimited files, XML, whatever you have in mind. It's just a message of text that gets sent to a waiting line and then retrieved from a different computing process. And we saw this with web jobs. I think, again, that was the canonical example where one console application dropped in a message into a queue, and then a web job kicked off another console application that read the message off the queue. Hope you remember that from the previous course. And so, again, this is an exciting feature. It enables entirely new ways of engineering scalable systems that can stand up to the heaviest imaginable processing loads. All right, so let's talk about getting started. To use a Azure Storage service you have to create a new storage account. So you go to Data Services, Storage, Quick Create, and then you'll give this a URL. So this is my example .core.windows.net. We've talked about affinity groups in the previous course, so I'm not going to go through those again, but all the old affinity groups, all the old locations are still available to us, so I might choose East US. And then I have some choices about redundancy, and this will affect our costs, so I'm going to wait to talk about this in a little bit. But I can choose to have locally redundant all the way up to zone redundant data storage. And so let's go ahead and just create the account with geo redundant. And you can see that we're creating a storage account called This Is My Example. And after a few moments, when the storage account is set up, you can, as we saw earlier, you can dive into it and set up monitoring, configure some of the options, create containers, and import and export blobs, I believe. You can also manage access keys like we learned about before. And then in addition to this, you may often need to give users who are not admins within your organization, you may need to give them access to the data or the content that's stored inside of blobs in particular, although I guess this could be used for tables and queues as well, usually used with blobs. And to accomplish this, you would create a shared access signature to grant access to those resources for a limited amount of time. So the canonical example is that you have some protected content on your website and you want to give your members access to that content. You can give them a hyperlink with a expiration date in time, and after a certain amount of time, then that link is no longer active. And so you do that using shared access signatures, and I'll demonstrate how to set that up in an upcoming module. So finally, let's talk about costs. And to talk about some of these things, I want to point out two URLs. This module was based mostly upon the information in the URL that you see on screen right now. And as you get down to two concepts in particular, the replication and costs, these kind of go hand in hand. So let's talk about the different kinds of redundancy that you have available for you with your storage accounts. There is locally redundant storage, and it says that this maintains 3 copies of your data. It's replicated 3 times within a single facility inside of a single region. So you can see that locally redundant storage protects your data from normal hardware failures, but not from the failure of a single facility, and it suggests that you use geo-redundant storage instead. The next step up from locally redundant storage is zone redundant storage. Still maintains 3 copies of your data, but it will replicate it across 2 or 3 facilities within a single region or across 2 regions, providing higher durability than locally redundant storage. Then we go up to geo-redundant storage, and this allows you to maintain 6 copies of your data. Your data is replicated 3 times within a primary region, but it's also replicated 3 times in a secondary region, hundreds of miles away from the primary region, providing the highest level of durability. Okay? And then there's one final option, read access geo-redundant storage. This is the newest of all the options and provides all the benefits of geo-redundant storage, but it also allows read access to data at the secondary region in the event that the primary region becomes unavailable. So this goes beyond just redundancy and makes the data available in kind of a hot swappable scenario. Now, you can't talk about these options without talking about pricing, because it affects the price that you'll pay for each of the services. And so here you can see on screen a URL that'll take you to this page that discusses storage pricing. First of all, notice that your total cost depends on how much you store, the volume of storage transactions, and outbound data transfers. Not only that, but also which data redundancy option that you choose. All right, so here we go from locally redundant storage all the way up to read access geographically redundant storage. Nice breakdown again of the difference between each of them. And then you can see that here's the pricing for blobs for each of those options. You can see that read access, geo-redundant storage is over twice what locally redundant storage costs, and that makes sense. There's also pricing for tables and queues. Now your queues probably won't rack up a lot of long-term data storage. However, what you do see with queues is storage transactions. In fact, every time you read or write to your storage account, it's going to cost you 36 one-thousandths of a cent in US dollars per 100,000 transactions for all storage types. In addition to this, you'll have to pay extra for outbound data, and that's at a whole different pricing schedule than what you see here. And that is calculated here. And it depends, again, like we saw previously with Azure websites, on intra-zone communication. Now, if you're within the same zone inside of an Azure data center, you don't pay anything for data transfers, but outside of a zone, then your costs can rack up pretty quickly per gigabyte. Okay, so that pretty much wraps up everything that I wanted to say about Microsoft Azure Storage for this module. We talked about the different services, what their intent is, some of their distinguishing features, what their costs are, understanding the redundancy that's baked in, how that would affect our costs. Now we're ready to dive deeper into some of the topic matter that we've introduced in this module and the previous module. We'll talk about the emulator and the Azure tools for Visual Studio, the next couple of modules, and then we'll begin diving deep into tables, blobs, and queues. So this is where things start to get interesting. We'll see you in the next module. Thank you.